Hello again and welcome. Today I'm going to go over a recent repair that I made on my motorcycle cluster. So actually I had two clusters that were bad. This is off an earlier Suzuki Hayabusa. This is off of my bike. You can see the cluster's a little different in the lettering. This cluster never worked. I have not put the screws in it yet. But what was wrong with it is the stepper motors wouldn't turn. And there is a stepper motor controller chip that's located between these two gauges. So what I ended up doing was buying a dead cluster, and this thing was really dead. I mean, I didn't do this to the gauges. This is the way they came off. You can just see this thing is just shattered. Here's the LCD for it, completely shattered. Notice how bent up the plastic is. So this is the circuit board out of it. See how that thing is warped? I'm guessing somebody died on this motorcycle. I mean, that was quite an impact. You can see it bent the circuit board enough it actually cracked the main controller chip. That's not a scratch. That's actually broke that IC right in two. It's a shame because I would have liked to have saved that part. This other LCD is still good. Well, the stepper motors are bad. You can see this shaft is actually bent. I don't know if you can hear that, but there's a lot of slop, and this thing is binding now. I believe that the stepper motor for the fuel gauge is still good, and that bezel is still okay. The LEDs are still good. Regulators are good. Notice the bent leads. It actually broke this resistor in two. There's a lot of physical damage to this board, but again, the part that I was looking for was this IC right here. So I removed the IC with a heat gun. I also pulled out the resonator while I was at it. This is the one that came out of the other circuit board. One of the changes that they made from these early displays to the current ones, this one being an older one, you'll notice that this new one, maybe if you look right at the IC, you can see it has a coating over it. So these boards are all conformal coated. The original one that I have here was not. So I'm assuming they had a moisture problem that was damaging the boards. I don't know if that's actually what damaged the stepper motor controller or if it was just an infant mortality problem. So now that we have the new stepper motor controller installed, we can go ahead and button this back up. And then we'll use our engine simulator to run a test on it. You're looking at my motorcycle simulator. The way this works again is it actually uses a standard ECM that's connected in the back. This goes off to a custom-made circuit board that resides inside of this PC. There's an FPGA, or a field programmable gate array, that's programmed up with a logic that simulates the motorcycle. Because the models to simulate a motorcycle are pretty intensive, I do a lot of that computation in hardware rather than in software. This is a stock ECM. This came off of a 2005. Typically what I do is I keep records as I program these things up. That's what all these markings are on the back here. So for example, with this motorcycle I use an auto shift, and I can set those shift points inside of the ECM. I can also set the rev limiters and how those function, along with playing with the fuel and timing maps. Alright, let's go ahead and we'll turn on the power. Notice that all of the displays light up. That's a good sign. You can see the motorcycle had about 24,900 miles on it. Notice when I powered it up, all the gauges go through a self-test. So the ECM drives them all to one extreme and then back to the other. You can see our coolant temperature is set hot right now. What I'm going to do is just dial that down. See the motor's cooling off, and you can see the warning light went out. And now it's cold. You can also change the neutral indicator. And this is the oil pressure sensor here. And let's go ahead and we can start the motorcycle. So I'm just going to run this thing in closed loop mode. And let's go ahead and start it up. You can see how the idle is coming down. Now notice that the display here is showing just a little over 1,000 RPM, but the tach is actually reading a little lower on this. Let's go ahead and let's compare it against the data going to the display. We'll just fire up our data logger and let's try a power cycle. There it goes, so it's initialized. Now you'll notice that the data logger is reading the same value that our simulator is putting out, but again, notice how the display is off a little bit. Now you may think, okay, you could just move the needle or do something with it that way. Now, unfortunately, the way that this works again is it aligns to these dead stops. So there's nothing really that you can do to align it. The other problem is as I increase the speed, so let's just go to 2,000 RPM. You can see it's reading a little closer. Let's go to 3,000. You can see it's a little closer, but it's still low. Let's go to 6,000. And now you can see it's spot on the money. And let's go to 8,000. And now you can see it's reading a little bit high. Let's go to 10,000. And you can see it's reading even higher still. And let's try it at 12,000. And now you can see it's reading quite a bit higher. Let's say we mechanically move this needle so it was reading right at the lower RPM. You can imagine at the higher RPMs it's going to read much higher than what it is now. So here it's probably over 13,000 RPMs it would be displaying. Now again, if you look at the logger, you can see it's dead on at 12,000 RPM. So the ECM is telling the cluster it's at 12,000, but again, the cluster has this inaccuracy to it. But if you go out on the forums and you read about these earlier Hayabusas, you'll see that that's one of the customer complaints, is that the gauges are wrong. So let's look at the mile per hour gauge. So we'll take the bike out of neutral, release the clutch, we'll just put it into first gear. So you can see our simulator is running it at basically 86.9, 86.6 mile per hour. And you can see our cluster is showing just a little bit over 85 miles per hour. But let's go ahead and slow this thing down a little bit. I'll turn off the audio. So here we are at 27 miles per hour. And you'll notice that the gauge is again reading a little below 20. Let's try speeding it up. We'll go into 6th gear. And now let's take the RPM back up. So here we are at 160 miles an hour. And you'll notice now the gauge is displaying about 167 miles per hour. So as we increase the speed, the gauge reads high, but as we slow down, the gauge reads low. Let's make sure that the fuel level system works. What I'll do is I'll just decrease the amount of fuel. I'll reset the gauge. We should see this warning light come on, basically showing that we have a low fuel state. Try running the engine model. You can see it's up against the rev limiter. Let's take the throttle all the way open. Let's put the bike into first gear. And now we'll release the clutch. Now we're up on the upper rev limiter. We'll chop the throttle, pull in the clutch. And now I'm going to replace it with a newer one. Again, this is the one that is actually on my motorcycle. Now this particular cluster has a modification. What I've done is I've replaced the low quality resonator that they use for the timing source on this with a much better oscillator, and then I've trimmed that in So let me just show you how accurate this is. Maybe it's about the same. It's been a while since I ran a test like this. Alright, let's go ahead and we'll turn it on. And you'll notice that we're currently putting out about 574 RPM. Let's just make this an even 500. And that should be the very first tick of the display. You can see we're putting out about 7.4 miles per hour. And the display is just over 1 tick. So very close in this case. So let's go ahead and increase the RPM. We'll go to 1,000. You can see it's a little low right here. The mile per hour is 14 and it's just under the 15 mile per hour tick. Let's go ahead and increase this further. We'll go to 3,000 RPM. And you can see it's pretty accurate right at 3,000. And it should be 44.2 miles per hour. And you can see it's just below the 45 mile an hour tick. So much better. Let's increase it further. Let's go to 6,000 RPM. And you can see it's basically spot on. The speed should be 88.3. And you can see it's reading about 92 miles per hour. Let's go up even higher. So this would be 8,000 RPM. And again, you can see the display is spot on at 8. Should be about 118 miles an hour, and you can see it's showing about 125. Let's go up to 10. And you can see the cluster is pretty much spot on at 10,000. It's reading a little high now. Mile per hour wise, it should be close to 147. You can see it's reading about 155. And let's go up to 12,000. It should be 176 mile per hour, but you can see it's actually buried the gauge. The tachometer is basically spot on at 12,000 RPM though. We'll go ahead and increase the engine temp. You can see the warning light kicks on. And let's just go ahead and drop the fuel level. Again, the fastest way to get this thing to reset is actually to restart the engine. So it looks like our original cluster is now 100% functional. Again, the other cluster that came off of a wrecked bike didn't really cost me anything, so I was glad I found those ICs. Those things are very hard to find. I think the only way that you're going to get any of that is by using a donor cluster like the one that I found there. Well, that's going to be it for this short video. Hope you enjoyed it. Till the next time, we'll see you then. Later.